Hello, Assalamualaikum. I am Ananya binti Abdul Halim with Metro ID CA19084. Will present to you guys about the software-defined networking, which is SDN, in cybersecurity. Before I go further, let me tell you a bit about software-defined networking, which is SDN. So SDN is a networking method that employs software-based controllers or application programming interfaces, which is API, to communicate with underlying hardware infrastructure and direct network traffic. So for your information, SDN is different with the traditional networking. So the key difference between the traditional networking and SDN is from the infrastructure. So the traditional networking is the hardware-based networking where it uses switches or routers to control the network traffic. But for SDN, it controls the network via software. So SDN is significantly more adaptable than the traditional networking. This is because it enables network managers to operate the network, alter configuration settings, provision resources, and enhance network capacity, all from a centralized user interface and without the need for additional hardware. So SDN works according to the three parts of SDN architecture, which are application layer, control layer, and also the infrastructure layer. So in SDN, the software is decoupled from the hardware. And then the SDN move the control plane that determine where to send the traffic to the software and leave the data plane that actually forwards the traffic in the hardware. So this will allow the network administrator who use the software-defined networking to program and control the entire network via a single pane of glass instead on a device-by-device basis. Now we will move to the next part, which is introduction of cybersecurity. So cybersecurity is the activity of securing vital systems and sensitive data against the digital threats. So cybersecurity measures, also known as information technology security, are intended to prevent threats to network systems and applications, whether they originate within or outside of a company. Today's cybersecurity business is confronted with a more capable collection of threat actors employing new plans, tactics, and also techniques. So the threat actors can use advanced tools to carry out multi-phase campaign to achieve their goals. So while the defenders are improving their ability to model, visualize, and understanding boost attack techniques, as well as finding weaknesses in their organizational defensive posture, there are still substantial hurdles in how the defenders approach responding to these sophisticated attacks. So now we'll move to the issue in cybersecurity. So according to Arbor Network's 2016 Worldwide Infrastructure Security Report, the number one threat against service provider customers is DDoS attacks. So most DDoS attacks are brief but frequent, and they can be detrimental in a variety of ways. So they are employed not just to disrupt an organization's operations, but also as a decoy while offenders enter other portions of network. Not only that, according to Arbor Network, while 86% of attacks last less than 30 minutes, 37% of respondents say that they are attacked 50 or more times every month. So according to 36% of the respondents, it takes 10 minutes or more to mitigate the assault, and downtime result in a measurable economic expense. So approximately 45% of commercial, government, and education groups reported that internet outages cost them $1,000 or more per minute, with 14% facing expenditures of $5,000 or more per minute. So now we'll talk about how we can relate the SDN and the cybersecurity. So in the fight against the cybercrime, software-defined networking, which is SDN, and a varied collection of SDN-based security solutions will gain traction quickly. So SDN can make it easier to collect network usage data, which could lead to better algorithm design for detecting attacks. So better informed SDN agents will be used by the next generation of apps to improve policy enforcement and traffic anomaly identification and mitigations. So these apps may be able to prevent hostile attackers from entering crucial network areas. Now we move to the next part, which is the advantages of SDN in cybersecurity for the current time. So the first advantage that I get is SDN avoids the misconfiguration issues by automating the security provisioning and reducing the time to restore system functionality after an attack. So SDN will abstract and centralize the network configuration and management operation at its core. So it also will allow the external application to control the network's behavior by making it programmable. And then these apps can automate and simplify the network device configuration, making the network more dependable and easier to debug. So next is the control instructions separated from the user data flow. So once the control instructions are separated from the user data flow, the data flow can be modified and changed as needed for the network connectivity and security advancements. So the abstraction of the data plane allow for increased ability to establish and implement security policies based on the abstractions. No field servers can be used to conduct the network control functions. Similarly, the security capabilities for detection or mitigation can be separated from inspection and mitigation or control activities, where those mitigation or control process execute on more generic. So as a result, the security must be ensured for the apps themselves and not just the system that hosts them. So the third advantage of SDN in cybersecurity is greater control and security by micro-segmentation. So micro-segmentation of networks and business process enables enterprises to provide unique connections between the users and their data center running business applications. So this strategy allows the enterprises to have different security settings for each person, application, and also the business process. So the results in fine-grained security rules in the company and adopting security to match with this new approach to network security is more simply implemented to give fine-grained management and, more crucially, greater security of micro-segments. So the fourth advantage is management of the Internet Things, which is IoT, and their security. So as enterprises rapidly deploy IoT devices, the issues of segmenting business operations and associated application from IoT traffic become greater. The function of the security techniques that adapt to IoT in the environment necessitates a much more fluid and agile approach to policy definition and monitoring policy enforcement. So lastly is the remote or branch connectivity and its security. So larger organizations with branch offices are used to connect those offices with a single connection. As the firm evolves, the network and business application requirements for those branch office have changed to necessitate multiple types of network connections, so as well as the network management. Security for branch office and business application can benefit from the network's agility and automation enable an SDN-based approach, but it also can be applied to the security services. So for the last part of the presentation, I will tell you guys about the advantages of SDN in cybersecurity for future. So the first advantage that we can get is the automated security provisioning and orchestration. So SDN can be used to simplify and automate network provisioning when changes occur inside a business application and server infrastructure to reduce vulnerabilities caused by the misconfigurations. So customers and administrators, for example, they can use the cloud orchestration technologies to swiftly construct, transfer, and destroy the virtual machines within their computing environment. So by combining a cloud orchestration tool with an SDN controller, the orchestration tool can send changes in the computing environment to the SDN controller, which then automatically and reliably reconfigures the network to enable the changes to the VM environment. So next is the automated detection and response. It is vital to reduce the time it takes to respond to cyber attacks. SDN controllers can immediately prohibit harmful traffic flows, route suspected to the network forensic tools for additional investigation, or quarantine suspect traffic. To automate this operation, an SDN application that can accept inputs from the security tools, intrusion detection systems, and the other network monitoring devices is required. So when an application identifies the potential threat, it alerts the SDN controller, which instantaneously and automatically reconfigures one or more networking devices to refuse, quarantine, or further de-analyze to identify the traffic flow. So the last advantage of SDN in cybersecurity for future is the proactive defense. So in more advanced use case, the network becomes proactive in its defense against the cyber attacks. So this could include constantly rearranging how the data is routed through the network, reassigning the IP address, and implementing other procedures to confuse the potential attackers. And this also can make the attackers hard or difficult for them to launch their successful attack. But while this proactive method requires additional refinement, it is made possible by SDN automation and has the potential to decrease an entire class of exploitation tactics. So this will improve on the present focus of only recovering from attacks by limiting exploits. So I think that's all from me for this assignment, which is the software-defined network. And thank you.